Imagine waking up one day and every familiar thing around you, your home, your city, even your planet, is getting bigger, expanding. But why? Well, this is precisely the enigma that cosmologists are trying to unravel. You see, the universe in all its vastness is not static, it's expanding. And not just at a leisurely pace, this expansion is happening at an accelerating rate. That's right, the cosmos is not lazily stretching out, it's racing away at breakneck speed. The stars, galaxies, and even the very fabric of space-time are all part of this cosmic sprint. But what's pushing them? What's the energy source for this universe-wide acceleration? The answer to this question has been eluding scientists for decades, and it's one of the biggest mysteries in modern astrophysics. And the reason behind this cosmic growth spurt? It's something we call dark energy. Dark energy. Sounds like something out of a sci-fi movie, right? But it's very real and it's all around us. Let's dive into the enigma wrapped in the cosmos, the elusive dark energy. In the simplest of terms, dark energy is a mysterious yet fundamental component of our universe. It's an unknown form of energy that's believed to permeate all of space. Imagine it as a sort of cosmic anti-gravity, pervading every nook and cranny of the universe, invisible to the eye yet undeniably present. But what does dark energy do? Well, it's the unseen puppeteer pulling the strings of the universe's expansion. To understand this, picture yourself baking a loaf of raisin bread. As the dough rises, the raisins, our galaxies, move farther apart from each other. The dough in this case is the fabric of space itself, and dark energy is the yeast causing it to expand. The role of dark energy in our universe is pivotal. It's hypothesized to constitute about 70% of the total energy in the universe. That's right, the majority of the universe's energy is in a form we can't directly detect. But here's the real kicker. This expansion isn't just happening, it's accelerating. This was one of the biggest surprises in modern cosmology. The galaxies aren't just drifting apart, they're speeding away from each other at an ever-increasing rate. And dark energy is the prime suspect behind this cosmic acceleration. So, to sum it up, dark energy is the universe's backstage director, orchestrating the grand spectacle of cosmic expansion. It's the phantom energy, unseen and undetected, yet its effects ripple through every corner of the cosmos. It's the force that's pushing galaxies apart and causing the universe to expand at an ever-accelerating rate. In essence, dark energy is the unseen force driving the universe apart. It's the enigma that keeps scientists up at night, the mystery at the heart of our understanding of the universe. It's invisible, it's pervasive, and it's one of the greatest puzzles of modern science. So, how do we know dark energy exists if we can't see it or touch it? Let's begin with the distant supernovae. Supernovae are exploding stars that shine so brightly, they can be seen from vast distances. Scientists use these celestial events as cosmic yardsticks to measure the universe's expansion. In the late 90s, two separate teams of astronomers observed these distant supernovae and made a startling discovery. The supernovae were not just moving away from us, they were accelerating in their retreat. This finding suggested that some unknown force, which we now call dark energy, was driving the universe's accelerating expansion. Now, let's talk about the cosmic microwave background, or CMB. The CMB is the afterglow of the Big Bang, and it blankets the universe in a nearly uniform glow of microwave radiation. By studying minute variations in this glow, scientists can infer the universe's composition and evolution. What they found was that only about 5% of the universe is made up of normal matter, the stuff we can see and touch. Nearly a quarter is dark matter, and the rest, a whopping 70%, is dark energy. Finally, there's the large-scale structure of the cosmos. When we look at the universe on large scales, we see that galaxies aren't just randomly strewn about, they're organized into vast filaments and clusters with enormous voids in between. This structure is thought to have arisen from tiny fluctuations in the density of the early universe. However, without dark energy, gravity would have pulled everything back together by now. The fact that we still see this cosmic web tells us that something is countering gravity's pull. That something, we believe, is dark energy. In a nutshell, while we can't see or touch dark energy, we can observe its effects. From the accelerating retreat of distant supernovae, to the cosmic microwave background, to the large-scale structure of the cosmos, the fingerprints of dark energy are everywhere. Even though we can't observe dark energy directly, its effects are written all over the universe. The existence of dark energy poses one of the biggest questions in cosmology. What is it? This enigma, this unseen force that permeates our universe, is the subject of many theories and hypotheses, and yet, it remains largely unexplained. Scientists have proposed various theories about the nature of dark energy, each one more fascinating than the last. The most popular is the cosmological constant, first proposed by Albert Einstein. This theory suggests that dark energy is a property of space itself. As space expands, new space comes into existence, and with it, new dark energy. That's right, the universe might be creating this mysterious force as it grows. Another theory is quintessence, a dynamic, evolving field of energy that changes over time. Unlike the cosmological constant, quintessence suggests that the amount of dark energy in the universe isn't constant, but varies across space and time. Then there's the theory that we may need to revamp Einstein's theory of gravity. Some physicists propose that dark energy doesn't exist at all. Instead, the strange acceleration of the universe's expansion could be a sign that our understanding of gravity isn't complete. But despite these theories, our understanding of dark energy is still incomplete. It's like trying to solve a jigsaw puzzle with most of the pieces missing. We can make educated guesses, propose theories, and gather evidence, but until we find those missing pieces, the full picture eludes us. Dark energy is one of the largest unsolved mysteries in science. It's a cosmic conundrum, a question mark written in the stars. We may not know what it is, but we know it's there. It's a part of our universe, a part of us. We can see its effects, feel its influence. It's out there, in the vastness of space, shaping the destiny of our universe. While we may not know what dark energy is, we know it's out there, shaping the destiny of our universe.